In this video, I'm going to be going through how I use FreeCAD and 3D printing to solve everyday problems with my stuff. My problem here today is that I have this USB document camera, and the way it hooks up, either through the back here, it has to be oriented in a way that this document appears upright. So we have this place to mount it on the back, which is what this whole stand that came with it was intended to do. And then you can also flip it so it's horizontal instead of pointed down at a desk. And it has this mounting point at the top, which is kind of intended to be used like that. However, every now and then I would like to put this on a tripod, like if I'm trying to capture a time lapse of a print, or really if I need a camera for anything else. This is my go-to. But as you can see, if I flip it over, it doesn't have a place to mount on the bottom. So I can't just stick it onto a tripod and call it a day. I want to make something so that I can attach it through the top and then attach this thing that I'm going to design onto the tripod itself. So how are we going to do that? So basically my idea is if I have the end of my camera and then I want to make a frame that will go around that, just kind of like that, if you can see, and then I will have a place to mount my screw, which would be this one, on the top, and then on the bottom would be where we have our tripod. I'll just draw that there. Let's take some measurements for the camera first. That's the width. I'm just going to go 43, and then for the height, it falls at around 47, and then for the depth, well, that actually doesn't really matter. But what does matter, and what I'm trying to kind of base it off of so I get the best chance of this being compatible, is this piece right here. That actually it looks like it's attached by a hex wrench, but I don't have to take it off, honestly. I can just measure a couple of things here. I'm getting 19.5. I'm just going to round that up. Then I'll measure the height, and it's about 14.5. Or I'll just call it the thickness, actually. The length we will have to calculate from a combination we'll get to here in a second. I want the diameter of this hole here, which appears to be 8 millimeters. Okay, and with that, we should have enough information to actually start getting this design going in FreeCAD. And the first thing we're going to do is I'm going to go into the Spreadsheet toolbox or Workbench. Okay, so here we have just a blank spreadsheet. So the first thing I'm going to go ahead and do is start typing out our camera measurements. So I did the cam width, which is going to be 43 millimeters, cam height, 47 millimeters. And then I'm going to come over to this side actually, and I'm going to do the frame depth, 20 millimeters, and the frame thickness, 14.5 millimeters. The whole inner diameter, please keep note that that's diameter. I'll explain more about that later, and that's 8 millimeters. Now we can do all of our calculations. And I think it's actually kind of funny. I'm using a webcam right now. I would be using this camera for something like this. I actually almost started recording with this. I almost hit record before realizing, like, wait. So basically, I want there to be some spacing between this camera and the frame. Just like a little cross section of what I mean right here. So that's where the camera is. And then I just want some spacing all around that. A spacing of 10 millimeters is good. So I'll just go ahead and add that here. Well, actually, let me move that here. All right, so now I'm just going to select all of these, and I'm going to use my easy alias macro. And what that does is it turns all of these selected things, and it looks to the cell next to them, and it'll actually give it that alias. Basically, living up to its name, aliasing things very easily. If I wasn't, let me go ahead and make my first calculated thing here, and I will call it the frame length or height. We're going to calculate this dimension with that spacing. It's right here. And the reason why I wanted to easy alias these first was because I would have to do something like B2 plus E what is that, 4? Maybe these have to be caps. You see we get our measurement here, but what is this? Like when we have to come back, say if the calculation's not correct, we go back to our part and we see that something's not lining up right, we're gonna have to go, oh, okay, so what's B2? B2, 47 millimeters, oh, and that's the cam height. And then we have E4, which we figure out, oh, over here's the frame spacing, but we're not here to play chess, right? So what I like to do is I do that easy alias, and then I can just do my aliases, so cam H plus frame spacing. And you see we get the exact same answer with our aliases, and we don't have to like do this whole hunting what row and column it's in. We can see, oh, cam H, okay, 47, cool. So let's do the same thing with the frame width, and we'll say equal cam width plus frame spacing, but I'm going to say times 2. Unlike the height here, which you could probably barely make out. So this is just 1 times the frame spacing, and when we go across these ways, we have 2 times the spacing there. So you see, that's why I multiply it by 2 there, so that way it's nice and even on all 3 sides where I'm going to have the spacing. One more thing that I need, it is just a hex nut that's going to fit the tripod screw and basically allow me to put this bottom part onto a tripod. This is the threading, so I'm not going to use a heat insert or anything. I'm just going to use this bolt or this nut from a kit. I'm just going to measure, so you see I have these straight parallel sides. That's 10.7, so yeah, I'll just say 11 millimeter just to give it a little bit of clearance. Another thing I forgot is the height. How deep does this go? And I'll just say 8 millimeters. It's at 7.8, so cool. So now I believe we do have enough information here to actually go ahead and start building our object, our little frame. So let me go ahead and, so now we're going to switch over to our part design workbench, and I'll just kind of give you a run through of these tools really quick because there are not a whole lot to see until we actually start working in the sketcher. So this is going to be our create body, which I'll go ahead and click that now. And if I go to our model tab, you can see we have our body. And I'll just go ahead, yeah, we'll just leave that as body for now. And then we have the new sketch button, which we use very often here in the part design workbench, but I'm not going to click that yet. We have different things for creating what are called like datum geometry. And I don't really use these a whole lot. I do use these shape binders. This blue one I use. Then we have our pad, which will extrude a surface along an axis, or like along the z-axis of your sketch. Then you have a revolution, which basically spins it across an axis of your choosing. The additive loft, which basically morphs between 2 different shapes, but it does have its limitations. A pipe, so you take a sketch and, or like a profile as they call it, and you basically drag it across that thing, that path that you have. An additive helix, basically the same thing as the pipe, except you sweep your profile along a helix, kind of like a screw. And then create an additive primitive. I've actually never done before, but as you can see, it just creates a box or any of these that I guess you choose. And then all of these blue ones are kind of like the same thing as this, but like the anti version. So with a pocket instead of a pad, you're removing material depending on the length and everything. Hole I haven't actually really used, but I think that just cuts out everything like along that sketch. We have the groove, which is like a revolution, except it subtracts the material. The subtractive loft, same thing as the additive loft. We'll get used to these tools a little bit more. I think for this, I'm mostly going to be sticking to the pad and pocket, but we'll see where this takes us. So Now I'm going to go ahead and hit create to sketch, and I'm going to do this on the XZ plane, and you can see that this box says that we're facing the front of our object, which is ideally how I would want it to be. Before I actually get started here, I'm going to go through and explain as many of these tools as I know. I'm going to really brush past a lot of them. Starting at the top here, I'm going to go skip through all these. I really have not used any of these. I think some of these are for the view. Yeah, so set to front view, top view. You can also use this little box right here, which is, yeah, I find myself using this thing a lot. So the parts that I really care about here are all of these geometry things, and then all of these constraints are the most useful. So here we have a point, a line, an arc, circle, which you can change between how that circle is constructed, a conic, and again, you can change how that conic's constructed. This is a B-spline, which I don't use unless it's actually like a drastic measure, because these are, in my opinion, are really hard to work with. We have the polyline, which allows you to create like any of these by cycling through them using the M key. And then you have create rectangle, and there are different ways you can create that rectangle. I just recently learned about this one while making this video, so I'm going to be using this one a lot, actually, the centered rectangle. And then we have regular polygon, which you can choose between. But then if you needed something that's other than any of these defined shapes, you can just click this regular polygon, and you can see it gives you an option for the number of sides. This is going to be for a slot, which I believe is like a kind of like a capsule more than an ellipse. I believe the conic is what creates an ellipse, and this just kind of creates a capsule type thing. Fillet basically creates a curve in your object. I like these, they're nice. I use the constraint preserving sketch fillet a lot. And then trim edge, extend edge. I don't really use any of these either. I do use this toggle construction geometry, and if I click it, you can see these icons turn from blue to white to blue to white. And what that means is, like, when they're white, this is geometry that's actually going to be constructed in your object. And if you toggle it to blue, these are what are called reference geometry. So anything that you draw with this blue line, or like, I guess, yeah, with these blue lines, they're going to be for reference only and don't actually show up in your object, which is really useful for when you're trying to constrain things down the line. And who knows, hopefully we'll get to demonstrate that with this object today. That will conclude it for our construction geometry. These are our constraints. There's no reason I shouldn't be able to demonstrate some of these. So if I create two lines and use this one, you can see now they're both together. The second one here is if I were to click a point and then click a line, and now you can see it actually follows through and to out the end of the line. That's just because it's constrained to that vector. Constrain vertical, constrain horizontal, constrain parallel, constrain perpendicular. That makes it so that they're always at a perfect 90-degree cross to each other. And then we have constrain tangent. This works better demonstrated on a circle. Take this and then constrain this here. And now you can see it's constrained to the tangent of that circle. We have equal, so for two lines, we can just hit the equal and they will always be the same length, no matter how they're oriented. Okay, and then we have symmetrical, which I can't really demonstrate here, but I will demonstrate it later. Constrain block, I haven't actually ever used. Let's see what that does. So it just basically freezes something wherever you want it. So I can just constrain block, constrain block, constrain block, and now, bam, we're fully constrained. That's a really interesting way to do it. If you didn't want to have to rely on actually measuring everything and having to create a bunch of convoluted constraints. But to me, that's part of the fun. That's some of the therapeutic aspect of it. So then we have constraint horizontal distance. So if I were to do that here, 2.7 millimeter, and now you can see the horizontal distance between those 2 points has been constrained. Same with the vertical distance. I can do that. And now I can no longer change how far. The length can still change, but the distance between those 2 points stays the same. And I feel like that's something really important to recognize about FreeCAD in order to be a successful designer, is learning how these constraints work with each other and work with your geometry. Then we have constrained distance, which, bam, there we go. That one actually fixes it. If you have like a diagonal line, it actually fixes it so that that line can't move anymore. Next we have constrained radius, which comes back to what I was saying here with the diameter. We've measured the diameter of this hole from end to end. In order to constrain that by the radius, we'll have to divide that by 2. Because this is the radius constraint. This is what I like to use, even though I still get mixed up a lot and probably should change to constrained diameter. But I am stubborn and will continue to use constrained by radius. But you get the option, whichever one you're most comfortable with. And then we have constrained angle. So let me go ahead and constrain radius. Yeah, you already saw that works. And now I can move it around, but I can no longer change its size. So now we also have constrain angle. So if I were to click here and constrain it to here, I'll type 45, and now you can see that this line will always be at a 45-degree angle to that origin axis. Similarly, you can hit the toggle button here to toggle the driving or reference constraint, and it turns these blue, because then if I were to click here, you can see I don't get that menu in to type in a measurement, because that's just going to keep track. It's going to create a reference so I can see how long a space is without actually having to commit that to the model. Or maybe it's a measurement I didn't even make. Because these constraints, as you constrain your object, you'll see you don't really have to define as much. Those things that you skip out on measuring, you can still have a value for them that you can reference, and that's what those are really good for. So now that all of that's out of the way, let's actually start designing our object. So I'll go ahead and just start by creating a square, and now I'll use that symmetry constraint that I was talking about earlier. And the way you want to use it is just by selecting the 2 points you want to be symmetrical, and then their center point. So now we have a square directly in the center of our sketch. You can see here under constrained 2 degrees of freedom, that basically tells us our sketch can still move in 2 dimensions. So that's the X and Y. As you can see here, I'm changing the length and the height, or the width and the height. So what I'm going to do is I'm going to create my first measured constraint, and you can see I can insert length, but how do I use all of these values? Because I could just do, okay, well, I know that my frame height is going to be 57 millimeters. Do that, call it a day. But what if I change this, right? What if I decide that this is wrong and I do want 2 times the spacing, which I know I don't, but for example, now I have to go back in here, double click this and change that to 67. When in reality, what I could do is just hit this blue little button that's hiding up here. And this is our formula editor. So now all I have to do is refer to my spreadsheet and type in that alias name. So for me, it's frame height. And you can see that this grays out because now it's actually chained to a value here. And this turns orange, noting that this is a spreadsheet or like a formula value as opposed to just the measurement. So now I'm going to erase that. I only want 1 time spacing there, and you can see there it is, 57 millimeters. And okay, so now we have that updating. I want to go ahead now and create my frame width. And we always have to refer to it by its name or its alias. So this is the name of it right now. and this is the alias, and you can see the difference between that if I were to close this. And I'll just rename this spreadsheet really quick to dims, short for dimensions. And now I'll go ahead and click this constraint again. And now you can see I have dims. This alias just makes it easier to refer to instead of having to type in spreadsheet. But you can see I still do have a spreadsheet here without the angle brackets because that's the internal name of the document. That never changes. So we'll just go ahead and do dims dot frame W. Cool. And you can see that we have our box shape coming out. What I want to note now is that this box is going to be on the inside where our camera is. So like this drawing right here, I'm going to do it again, but really small over here. And then we want to create a border around that. That'll be the thickness of the frame. And that thickness was what we took when we took the frame depth. And so basically what we just made right now is this inner box right here. And we have to be careful with that because if we created our box here on the inside, we'd be in a world of trouble because, right, then that's getting too small for our camera. So we want to be sure we create this box on the outside. What we'll do is we'll use that same symmetry modifier. And now all I have to do here is constrain a pair of corners. So like, let me explain that a little more. So like here we have the top of this box right here, and then the top of this box right here. All I have to do is select 2 points. It can be this one and this one, this one and this one. Can't be this one and this one. It has to be 1 point from here, 1 point from here. And we'll do dims dot frame depth. And there you can see we're constrained there. And because it's symmetrical, this side won't move either. So now I'm going to do the same thing but with a horizontal constraint on one side. Dims dot frame depth again. You can see we have our box. And this is one really cool thing that took me forever to learn about FreeCAD too, is creating a shape around a shape, or like a shape within a shape, and this interior, like between the two shapes, is what acts as like what turns into the mesh. So I can close this here now. Let me remeasure this really quick because I think I was actually supposed to use the thickness. So no big deal, just go back into my sketch here, frame thickness, frame thickness. So now I'm going to go ahead and use our pad tool, and I'm going to make this symmetric to plane because you'll see here there's a, you can imagine like an axis here, like this is the Z axis where it's resting right now, and when I symmetric it'll make that in the middle, right? That, I mean, that should make sense. I want it to be in the middle because that's just going to make it easier to align everything else that I'm going to do for this project. So here I'm going to go do dims dot frame, and this is the depth. Perfect. We have this all figured out now. We want to create the hole for this to go into the top, and then we want to create our hole for the nut to go on the bottom. But I'm not going to do just simple circles because the nature of 3D printing is such that circles just don't like to print. And I've learned that the hard way. I've been stubborn, but I've finally given into using hexagons or some kind of like more angular shape to kind of reduce the lip, so to speak, of that hole. So let's start by doing this hole on top. Or let's start by doing this on bottom. Now what a lot of people like to do is they'll click this sketch, or they'll click a face, and then they'll create a new sketch, and you'll see what that does is that anchors your sketch to that plane. But I feel like that leads to, I mean, it makes sense. It's intuitive. Don't get me wrong. I could do this, create my circle, or I guess in this case it's going to be a hexagon. So I can do this. I can create my hexagon. We'll just say yes, it's constrained, and then I'll create the hole, right? Okay. But I've heard that a lot of people have issues coming out of like doing it this way. So I'm going to show you the way that I do it, and I will explain. Well, I guess I don't really have to explain why. It just kind of makes it easier when you just create everything like without a reference to each other. When you change parts, as long as everything's parametric, it works really well to do it this way. So what I'll do is I'll just create another sketch, basically floating in midair. I'll put it here on the XY plane. And as you can see now, I can't really, I mean, I can still create stuff, but it's appearing underneath this object, right? So if I could click here, you can see that's where it is. But in order to be able to see through that while viewing it from like the top or whatever, you just hit Q and S, and that'll create a cross section for you. And now I can just go through, create my hexagon, and then if you remember from the measurement, it was from here to here. So I'll create my horizontal constraint from here to here. And we're going to do dims dot nut width. There we go. And that basically is it for that one. But now you can see that this this shape is just kind of hovering in midair, and I can cut through all the way to the bottom, but that's not really going to work for me because this nut has a specific height to it, and I don't want it to go any deeper, because then if it ends up any deeper and stuck there, the tripod thing won't screw in, right? So I want to place this on to the bottom side here, and I will do that by creating what I call an offset variable in my spreadsheet. So I'll call this the nut offset, and I'm going to set it equal to the frame height divided by 2. And the reason for that is because this is like the whole frame height right here from beginning to end. If we divide it, well, actually it'll be the interior here. So if we were to add that straight into like the bottom, we would go past this. So we would have like this distance, but right here. Dividing it by 2, make sure that we end up here at the bottom, and I'll go ahead and show you that really quick by giving this a name. And then on the attachment here, I'm going to do negative dims dot nut offset. And there you can see that it's already updated to show me that it's at the bottom of that frame, but I don't want it to be here. I want it to be here at the bottom and then push up these 8 millimeters. So I will go ahead and add to my formula plus it'll be the frame thickness. You see that brings us to 43 millimeters, and we are resting now perfectly on the bottom. So that's where I'll go ahead and hit my pocket tool. I'll have to reverse it because naturally a pocket wants to go negative on the z-axis of your sketch. And maybe that's something I'll get into another time, is like, what is the z-axis for your sketch? It depends. It depends on what face or what plane you make your sketch on. But I'll go ahead and reverse this, and then for most things you actually see there's a blue button. If there's a blue button next to it, you can attach a formula to it. So here on the pocket parameters, I'm going to go here, hit the formula editor, and do dims dot nut height. And there we go. We did that one. Perfect. So now we're going to do the hole for the attachment at the top. And so I'll go ahead and hit new sketch on the XY plane. Again, QS to make a cross section. And this one's going to be a little bit different. Let me tell you why. Because here we have a circle. No doubt about that. That circle is 8 millimeters, right? It's about 8 millimeters in diameter. And the problem that we have is that what I mentioned, circles are kind of preferred to like not have them in 3D printing. Especially like I'm going to be printing my frame sideways, and printing this circle up like that is not going to be very pretty. It's not going to look good, and at the end of the day this screw might not even fit in there. So what I'm going to do is I'm going to have to make a hexagon whose edges are tangent to this circle, so that this circle, or like this thread, will fit through. I just realized I was not recording my screen, so we'll do that again. So you can see I created this circle here, and I'm going to constrain its radius to the inner diameter divided by 2 because I'm using the radius constraint. And here's the problem that we have pop up, is that this circle now is exactly the same radius as that circle that's helping us define our hexagon. So naturally, if we were to come back here, this thread won't fit at each of those sides that that hexagon makes. So in order to combat that, I'll go ahead and erase this constraint. I'll go ahead and size this up, and then I'll use my tangent constraint to make those tangential to each other. And you can see it kind of aligns the whole circle now, and we don't have to worry about that. So what I'll do now is you can actually click any white geometry or any blue geometry, vice versa, and then click this toggle button, and you'll see that it toggles that. So now that's construction geometry as well. And what I'll do is I'll constrain that radius now to our dims.hole ID divided by 2. And bam. Now we have a hexagon that will fit our thread. You can close that now. And then the funny thing that we've done here with our bottom hole by creating that offset is that offset is exactly the same from here to here. So I'll just go ahead and do our formula editor, but instead of negating it, I'm just going to do the net offset. Bam, we end up there. I'm going to create a pocket, and its length will be our frame thickness. And it goes all the way through. Perfect. So this is basically ready to go, ready to print. I will go ahead and actually, let me go ahead and hit OK there. I just want to give this a little more of a refined look. So I'm going to go ahead and just start clicking, control clicking on Windows, all of these corners. Try not to select any faces. We got everything perfect. So now I'm going to create a fillet here, which I don't think I actually went through what all of those do, but we could go over them in another tutorial. So I just clicked this one right here. That's the fillet tool. Brought it up to 11 millimeters, and that is looking nice and good. So I'll go ahead and hit OK. All right, I will go ahead and export this, send it to my printer, and we will see how it works. As you can see, it fits perfectly, and I have absolutely no complaints. This thing is tripod ready for now and for the foreseeable future, but I do have another problem where the tripod I actually want to use this on doubles as a ring light, so I'm not recording in total darkness. But it has this shoe. It was meant so you can take your phone off of the ring light and attach it to a tripod if you wanted to, but that's not at all what I'm going to be using this ring light for. So what I want to do now is design a new one of these that will fit this shape. As you can see, it's got like a interesting little trapezoid profile there. So one of the things I'm gonna have to do is figure out what that angle is to the best of my ability to be able to make a piece that fits in there and is extended, so that way it'll fit the width of that frame, and then also I'll be able to screw it down from the bottom. Let's do width, and I'll just go ahead and say 31.7. Then the height, we'll do 5.7 as well. And then what I want to measure here is I made a mark that I can't really actually see anymore on how long it was from here to the edge. It seems to be about 22 millimeters, so we'll say give myself another 8 millimeters of clearance to make sure the frame has like as close to zero chance of connecting to that as possible. I actually have to get the angle here really quick, but that is going to be a problem because I don't know enough trigonometry to actually start putting that together. And if I don't knock down this light, nope, too late. I have this protractor, but I really do not think this is gonna help. So what I think I will do is I'm gonna take a picture of it, send it to my computer, and then we'll see if we can find the angle from there. So I now have my image open in GIMP. I will rotate it, and here's the picture that I took. So basically what I want to do now is I'm going to take this and stretch to each point here. Want to try to get like in a consistent location. I'll go ahead and hit straighten, and we'll straighten that out. And then what you can see here is that when I drag and then pull up, it's going to give me that angle, and that angle actually appears here at the bottom, 43.69. So yeah, that's about 30 degrees. And with that, we have enough info to keep working here. So I'm just gonna go ahead and add my shoe measurements, width, height, and I'll just call this the spacing, the clearance. All right, so now go ahead and easy alias all of that. Oh yeah, you gotta make sure that's selected in your hierarchy. There we go. I think that really should be enough. So I'll go ahead and create another body, the shoe. I'll create not a body, I'll create a sketch facing forward like that, if I can. Sometimes if you have intersecting geometry with the planes, you can hit V3, turn everything into a wireframe, select it, and then go back using V1. So what I'm doing now is I'm going to actually create the profile here so that I can include that angle. And what I'm going to do is just basically I select that polyline tool, and you can see what it allows me to do is just create a rough profile. That's actually pretty rough, but there we go. Now I've created this profile for my shoe, and actually what I'm going to do is I'm going to delete that. This just kind of makes it easier to align things evenly. So hit equal there. So if that's 30, then 90 minus 30 would be 60. So this is going to be 60 degrees. Same with that. Now we just want the width of this to equal our shoe width. And we want our shoe height. Alright, and now the only thing that's left, our last degree of freedom, is going to be on this axis here. So just to kind of keep in the spirit of things, I'm going to move this down here by the nut offset. That's going to put us right where we want to be on the bottom of that. I'm going to go ahead and close that. And now I'm going to further position this so that it's on the edge here. And as you can see, so here's where that Z talk kind of comes in, where I was saying the Z is dependent on what axis you made it in. What axis you were drawing. So whenever you draw something in a sketch, you can assume you're looking, even though it says from the front here, in respect to this sketch, to this geometry. When you're making this sketch, you're looking from the top down. So you can see when I hit Z, even though we made it on the XZ plane and we're technically moving it forward on the Y axis, on the positive Y, or I guess the negative Y if you're paying attention to this little thing here. It's moving on the negative Y because of how we were looking at that sketch. So this is just kind of like a little tip that I wish I knew. And you'll see if I use the Y here, that's what moves it up and down according to like the base coordinates. So just something to keep in mind. I'm going to make this by the frame. Don't forget to put your spreadsheet alias, and then by the frame depth divided by 2. And that's going to put us right there at the edge of that. Perfect. Now I'm going to just pad it out. And you can see it's going the opposite direction that I want it to go, so I'll just go ahead and reverse it. And I actually won't hit symmetric to plane because that's going to offset things, and it's not going to work out very well. I already have it aligned out to here at the end. I just want to reverse it so that we're going from out in. And I'm going to go ahead and I'm going to hit OK for now because I want to come back to my spreadsheet. I'm going to say shoe underscore length. Then I'm going to set that equal to the frame depth plus the shoe clearance. And that gives us 50 millimeters. I'm just going to call this shoe L. Oh, wrong box. Okay. Now I'm going to go back into our pad, double click that, and then in our formula editor, I'm going to say nims.shoe L. That's looking okay. But it also does have like this little slide here at the bottom that is, I believe, 1 millimeter depth here, and then this is 4 millimeters wide, about 17.5 millimeters deep. Wow, I did not record any of that. Wonderful. Okay, so our dent offset is going to be the distance from here to the nut offset plus the shoe height. So let me go ahead and say equals nut offset plus shoe height. And we'll go back in here. select those 2 points from the center origin here to one of these 2 bottom points. I didn't alias it, so I'll do that really quick. Okay, and then just to recap, I just created this box here, and then I deleted this edge and replaced it with 2 lines and made them equal, and then I made this the dent height here, this the dent width here, then we just made the dent offset, which is what we are going to attach here from the center point to one of these bottom points, and we'll say dims dent O, and that will bring us to exactly the bottom of that section. And then we want to bring it from this center point to over here, because that's where it goes, and that's going to be this half of the depth of the frame plus the spacing. So we'll just say dent placement equals the frame depth divided by 2 plus nut offset. And again, I know you're going to tell me that just clicking this and then making my sketch from there is going to be easier, but I prefer working this way. I've had not nearly as many errors as other people have had when working with this stuff, so I'm going to keep it that way. dims.dent p, and you can see it brings us all the way out over there because that's on the positive axis. We want to go negative, and as we can see, it's a little too far. So what's going on here? Frame depth divided by 2 plus nut offset. I don't know why I did that. It should have been plus shoe clearance. Not sure what happened there. Just brain didn't do that. It wasn't doing it for a second. Okay, cool. So now I can go ahead and make a pocket, and it'll have to be reversed. You'll see because it goes in now. And I'm going to make this length the dims.dent depth. So this is actually going to be probably the easiest part of the shoe. And actually, let me go ahead and I'm really playing with fire here. We're playing with matches here. I'm gonna call this the frame cam frame shoe. Okay, I'm gonna go to the plane XY. Just to keep with the aesthetic of everything, I'm going to do another hexagon. I'm going to do this. We're going to put this on the Z, negative, dims, nut offset. And we could pocket it by the shoe height. There we go. We have a little shoe that we can try to use here. I'm going to go ahead and print this out and we'll see how it goes. And here we have it. Everything worked perfectly. And now I have a decent camera for time lapses on my 3D printing. I really hope you learned something from this video, and I will catch you in the next episode. Thank you so much for watching.